Hi guys, welcome back to In Case of Econ Struggles. Today we've got another micro struggle for you. We're still talking about the profit maximization problem, but we're taking a quick detour into some cost functions, some different types of costs, and make sure that you like and subscribe to keep up with related videos to the profit maximization problem and other econ struggles. And let's get into our agenda for today. Today, we are going to talk about types of costs. We are going to talk about fixed cost, variable cost. Then we're going to talk about average costs. We're going to talk about these costs conceptually as well as their analytical relationships, how they relate to each other. Then we will look at our sample cost function and take it apart into those different costs. Then we will take a look at a graphical representation of those costs. And we will conclude by thinking about those graphs. So let's get into some costs. First, let's talk about this conceptually. So let's go back to our example where we own an ice cream store, and our ice cream store we make with machines. So we have these machines, and we have people. And if you remember, we commonly refer to these machines as capital or K, and we refer to our workers as L. Now, notice that the number of machines that we use, the number of workers that we hire, even though those machines are hard, they're relatively costly to put in and out of our store, we can still change those over time, just like we can choose to hire more workers if we're very busy, or we can let some of our workers go if we are not as busy. So those costs, those workers, that electricity that we need to run our store, we call those variable costs, which means that they vary based on output. So if I am making more ice creams, my variable cost might go up. And if I am making less ice cream cones, I might expect that my variable cost goes down. And the other part of costs we call fixed costs. So what is an example of a fixed cost? Well, we talked about before that maybe I have to pay the city that I operate in some money in order to operate my business. Maybe I pay rent. Maybe I don't own the building that I'm making the ice cream in. So those things, rent, licenses, any other cost that it does not matter how many ice creams that I make, I still have to pay those costs. Those are what we call fixed costs because, as the name implies, they are fixed. It does not vary with output. So if we go back to our example cost function, C of y, where y is the number of ice cream cones we're making, and we have y squared plus 5. Notice that this y squared, this varies with output. This is our variable cost, or VC as it is commonly referred. And this 5, this does not change based on the number of ice creams that we are making, does not depend on our y. So we call those our fixed costs and commonly denoted by FC. Now let's put that more into mathy terms, what we just talked about, mathy being the technical term. I'm going to denote TC, that stands for total cost, as fixed cost plus variable cost, which probably makes a lot of intuitive sense. Notice that I can also rearrange this to say that fixed cost is equal to total cost minus variable cost. And similarly, variable cost is equal to total cost minus fixed cost. So if I know two of these costs, total cost or fixed cost, I can find the third or variable cost. And any combination of knowing two costs, I can find that third cost using these equations. Now, a lot of times, and we'll see this in other videos later, it's not so much the total cost or the total fixed cost or the total variable cost we care about. We care about averages. So when I say average, I mean I want to know on average how much it costs me to make each ice cream. So for a numerical example, let's just suppose that I make 10 ice creams. It's my output, that's my y. Just put that over here, equal to y. And we still have C of y is equal to y squared plus 5. Now I can plug in the 10 here and get that this is 100 plus 5, which is 105, but that is not terribly helpful. What's more helpful is to say, well, my average total cost, my cost per ice cream averaged out is approximately 105, which is my total cost divided by the number of ice creams I made, which is 10.5. So on average, it cost me $10.50 to make an ice cream. And that is what we call the average total cost, or the ATC. Similarly to total cost equals fixed cost plus variable cost, we have average total cost is average fixed cost plus average variable cost. So average fixed cost is just going to be, in this case, that 5 from our fixed cost divided by y, or our quantity. And our average variable cost is going to be our y squared over y. So what we're going to have is our average total cost is going to be 5 over y plus y. Now we are going to look at this graphically as well. So we can put together a quick axis as soon as my line straightens out. So let's try that one again. Here we go. And we'll have our x-axis. Let's put y here. This is our output. And then here, I'm just going to put a dollar sign because we're going to have a bunch of different cost curves on this graph. So I don't want us to get confused. So we're just going to have dollars on the y-axis. Now, first, average fixed cost, I think, is easiest. So I will do that in green. Average fixed cost is just this 5 divided by the number of ice cream cones we make. So it is going to start relatively high, and then it is going to go something like an exponential decay function, where this point here, let's say this is 1 ice cream, this is the full 5 fixed cost. And as we make a bajillion ice creams, our average fixed cost, or our 5 divided by our bajillion ice creams, is going to be very, very, very close to 0. Now, our average variable cost is y. So our average variable cost in this case is going to be a line with a slope of 1. And our average total cost is just going to be the sum of these two, the sum of the average fixed cost and the average variable cost. So it is going to look something like this, where it's going to go like this and then become a line, because at some point, maybe I can make this look a little better. At some point, it is going to approach the average variable cost, because the average fixed cost is going to 0. So it is going to look something like this. Notice we can also put the marginal cost on here, where the marginal cost, or the derivative of the cost function, marginal cost. Remember, derivative of the cost function is equal to 2y, so we can throw that on here as well. And that is just going to look something like this. So once again, key relationships here: the average variable cost looks like a line, the average fixed cost is going down, and the average total cost is the average fixed cost plus the average variable cost. So here it's mostly following the average fixed cost, and then as the average fixed cost goes to 0, the average total cost basically becomes the average variable cost line. So I hope this was helpful. Make sure to like and subscribe for other videos, and we will see you again soon for another e-construct.